One of the things that I did not show you was this. What's this? Anyone knows? Yes. So naturally occurring magnets. And if you do take your compass, this doesn't show that very well. Where's the other one? Just this one here. So some magnetic materials. Oh, there you go. Can we see some remnants of, I don't know, maybe possibly iron, nickel, or cobalt? And we can see that, right? So touching the surface, 90 degrees, enough lines, north to south. Lines do not cross, right? These lines are vector lines, they're force lines. Model that we've got in school, and it helps you to see something. What does it show you? The field lines. What about the field lines more specifically? Oh, look at this. Are they all 90 degrees? What else? I think it shows you that these fields are three-dimensional. I'm just going to tilt it so you guys can see the compass, but it's not really good because then the compass are not freely rotating, right? So, 3, 2, 1. Oh, what did you see, young man? They all started to move. But be honest with you, because you can't see it there, I've got something else I'm going to show you, right? So, once I turn it on, can you see that? Can you see this magnet? Right, you can actually go in circles. And if I increase the voltage a bit more, I don't want it to go higher than that, very quickly. Right, and look at the field. What can you see about the field? The fields are circular. So here, I'm going to introduce something. There's something called the right-hand grip rule. So if you take your right hand, right, and you have your thumb pointing up in the direction of conventional current. What's conventional current? The flow of positive. The opposite of that would be the electron flow. If that's a conventional current, guess what this would be? The direction of the magnetic field. So up is easy, you could do it like that. Down is easy, you could do it like this. What about if it's going into the plane of the board? What do you do? How do you show that? How are you going to show that it's actually going into the plane of the paper in the exam? A point? Yes, absolutely. So we then use something similar to chemistry. We use a dot and we use a cross representing an arrow. So if someone is shooting an arrow at you and the arrow is pointing towards you, what do you see? The tip of the arrow, which is the dot. And if someone is, the arrow is going away from you, you see the back of the arrow, which is a cross. So if we apply now our right hand grip rule, and it's going into the plane, what do you see? The cross. So where's the field if it's going into? So what you'll have to do in the exam, you'll then have to do your direction like this, a full circle really. So what would that be? Cross, clockwise, right? And if it's a dot, it would be anti-clockwise and so forth. All right, good. So that's done. People who couldn't see that earlier, we've got something different now. Bigger compasses, bigger coils, right? And again, all I want to show to you, if we turn this on, there you go, they line up. You see the compasses? Shake them, randomly orienting. Where are they actually pointing right now? The Earth's magnetic field, north and south of the Earth, right? And look at it. Turn it on, they're all lining up in one direction. And to actually see that, look at it. Oh, actually, this one is more responsive. Can you see the feed line? Ooh, look at the middle. Proper, straight. And someone was asking about uniform field. That was you, Jawad, wasn't it? So if you want to get a really nice uniform field, you use a circular coil, because right in the middle here, you'll get a very nice uniform field. And here's the trick. This right-hand grip rule can be used in reverse. If this is the current, then this is the field. And if this is the current, then this is the field. So if you got this connection here, the current's going for the coil. So where's the current going? Like that. Where's this now? That's the field. Coming out. Which pole, guys? Which pole does the field lines come out? North. They come out the north pole. So right-hand grip rule used both ways. Current carrying wire has a magnetic field around it. Yes? Current carrying wire in a circular way has a uniform magnetic field that points outwards. Okay? Now, one wire, a set of magnetic field. Two wires, two sets. So if you increase the current, you can get more magnetic field. You can adjust that. And look at this one, right? Coiled up very nicely.